Welcome, welcome. Thank you everybody for being here. Literally all of my favorite people are here. Thank you guys so much for coming out. I know it's tough. You start class, it's in the second day, you got stuff going on, you're already kind of feeling the burnout and you're thinking about what you're gonna do the next day. And then you come here for more and it means a lot. Thank you so much for coming out tonight, for being here, and just for showing your support. My name is Joshua Wright. I am a SANS faculty fellow. I'm the author of SANS Security 504, Hacker Tools Techniques and Incident Handling. I've been teaching for SANS for over 23 years now, which seems like a very long time. And it's just been such a wonderful career. And the best part is being able to have an opportunity to talk about my favorite thing in the absolute world, cybersecurity, and to share it with all of you. Now, in addition to being a faculty and author member at SANS, I also work for a company called CounterHack, where we do penetration testing services. I'm a technical director there, where I lead a team of analysts doing wonderful work, penetration tests, incident response engagements, security assessments, and that type of work. And we also do a fair amount of work for the Federal Trade Commission, which means I get to see a lot of compromised details from organizations that get getting compromised, and then I'm able to use that for a lot of my other work as well. Today, I'm here to talk about a presentation series that I've been working on for a couple of years now. I do maybe a couple of these presentations a year that I call Hackventures with Josh. Hackventures is just a word I made up because I thought it would be great to Google. Maybe that was short-sighted. I don't know, okay? But this is a presentation about kind of what I've been going through and some challenges that I've faced in my career that I just kind of want to be open about and talk about, because I know that if I'm struggling with these things, I think other people are. And then I want us to have some fun. And so today we're going to talk about using AI for vulnerability discovery. So I'm going to start with an illustration. Has anybody ever seen this illustration before? This is from Vinny Liu, who is a wonderful research analyst and has done many great projects in his career. And he came up with this kind of illustration like on the back of a napkin. I'm pretty sure he made it in MS Paint many, many years ago. But on our x-axis here, we have our sense of self-worth compared to the number of vulnerabilities that we found in a given week of being a pen tester. And on the y-axis, we've got the days of the week. And this illustration, for me, speaks volumes about what it means to be a pen tester. In the beginning of the week, you're finding all these vulnerabilities, you're seeing these things that are going on, and then it starts to go downhill. And then you start to question your own self-worth, and you think, man, I suck. Like, who do I think I am? Maybe maybe I should become a Walmart greeter. And the more time goes on, the more you think you suck even more, and you're like, I can't do this. Maybe I should become a sales engineer. I hear they make good money. Like, I don't know. And you're just kind of going on your week there. And then something happens where you realize you found something that's magical, a vulnerability, something that's exploitable. And then now you're like so excited and you're engaged again. And then screenshots. And you're thinking, oh, please don't turn off VPN access. I need my access. And you continue, more time. I need more time. And then Friday afternoon rolls around and you spend the rest of your weekend doing reporting. And then you start it again the next Monday all over again. There is no more accurate perspective for what it means to be a pen tester that I've ever seen. And even though this illustration is like crappy and really old, for me, this is something that I look at and I think about a lot, because I think burnout is a really big problem in our industry. And about 5 years ago, I realized that I absolutely dreaded everything that I was doing. And I was doing pen tests and I was doing great work and I was helping customers and I was finding vulnerabilities, and I didn't like it anymore. I just wasn't having fun. Somewhere along the way, the work just stopped becoming fun. And that was really hard to realize, this thing that I loved so much, this work, doing these pen tests, finding these vulnerabilities, picking apart the little threads and seeing where they lead and using your own creativity to find these issues. I just didn't find it fun anymore. And so I thought, how do I make it fun again? How do we go back? How do we get past this kind of burnout mechanism where it was just engagement after engagement after engagement, and I realized that it was just work. And so what I decided to do was to try to connect back to the things that I loved about cybersecurity when I started my career in the late 90s and then continued through 2000 and the early 2000s when I started working for SANS and doing presentations and all the great work that I've done for companies over the years, and trying to get back to that. Why do we find this enjoyable? How can we get back to that area? This is something that I've been trying to work on. And so one of the things that I want to do in this presentation is have some fun. And sometimes that's picking on people a little bit for their security vulnerabilities, but I think that's all part of the learning process here. And so what I want to do in this presentation is kind of get back to why this is exciting, why this is interesting, and how we can have fun. So let's go ahead and we're going to have a little fun here. Let's talk about using AI for vulnerability discovery. This is major news. It's hitting major news outlets, not just in our kind of little community, but all over the world. People that are normies are seeing this kind of work, and people are understanding that AI is a tool that is discovering vulnerabilities faster than we ever have before. We've seen warnings from national governments. We're seeing all this insight where when you have source code to something, you can give it to AI and find vulnerabilities at a rate that's unsurpassed. Now, reading source code to find vulnerabilities is not a new thing. That's been going on for a long time now. But there's a couple of problems. When we do it as humans, we get tired, we get bored. We need some specialized training to find vulnerabilities, to do bug hunting, things like that. We need to understand the programming language of the source code we're looking at, whether it's C# or Java or Golang or Python or whatever it is. We also need expertise in understanding the native language of the human speakers. It's not uncommon to be looking at Chinese source code. I don't read Mandarin. I can read C and C++, but I don't know what any of these comments mean, and it's a lot of effort to try to turn it into something that's going to be more sensible for us. AI models just excel at all of these tasks, following code and logic trails, identifying patterns that identify potential vulnerabilities, making temporary harnesses to test and prove out vulnerabilities, running multiple tests in parallel, working tirelessly until all the goals are achieved, and then even understanding comments, translating language information. These are things that are hard for us that are actually really good for AI models. And it's maybe not a surprise that AI models are doing a really excellent job at using source code to find vulnerabilities at a rate that's just unparalleled. At the RSAC conference this year, I talked about, we had a presentation on the top 5 threats that you need to know about. I talked about 2 of them. One of them was the oncoming onslaught of supply chain vulnerabilities and supply chain threats. And when Team PCP and all the threat actors, I think that's really come true since we've talked about it. And the second was the threat of vulnerability discovery with AI, and how I just don't think as an industry, we're ready for the onslaught of hundreds of 0 days per week coming out in software that we rely on. Here's the key lesson that I want you to take away from this presentation today. AI-assisted vulnerability disclosure is broadly accessible, meaning a lot of people can do it without the expertise that used to be required, without a whole lot of understanding of the different programming languages, the human languages, without the time, the energy, the patience, and the dedication to read source code hour after hour. AI models make this accessible in a way that just has not been accessible before. But there's a wrinkle here. In order to use AI to really be effective at vulnerability discovery, we humans need to provide that orchestration layer. We need to be the ones to guide that, to think about the approach, to interpret the results. I think AI discovered vulnerabilities are a great boon for our industry. I think it's going to improve software security dramatically. But I think we also need to be a huge part of that. It's not just AI doing everything for us. We need to contribute to this as well. Zero-day vulnerability discovery requires your prep and the ability to access an AI model that can do this kind of analysis work. And I generally think of this as kind of a 5-step process. Step 1 is your step, your human step, where you build your understanding of the application that you're testing. Whether it's a web application or it is a library or some other software that you're evaluating, we need to have an understanding. What is it supposed to do? What's the potential attack surface? How is the application configured? What are the potential opportunities for me to attack and exploit this system? Then once we have that understanding, we need to build a target environment for validation of our findings. And we'll talk about why that's important and how we can do it. Then we need to build the scaffolding, take the test environment, take our understanding, and provide those resources, that scaffolding, to help the AI model understand what it's looking at and to have the best opportunity to find these types of vulnerabilities. Then we can drive the model, direct the model to find vulnerabilities, to validate, to assess, and to document these findings so they're valuable to us. And then at the end of this process, we need to apply our understanding again. Vulnerability reports in isolation have very little value for an organization. I've been a pen tester for many years. A lot of what we do in pen testing is not just finding vulnerabilities, it's explaining to the customer why it's important and why they should care. And that's not something AI models are good at, because you understand your business, your organization, way better than any AI model will ever actually understand. So let's go through this process. Let's talk about these different elements here, and we're going to pick on an application called Proxybolt Droppy. Now, Droppy is written by a software firm called Proxybolt. I'm pretty sure it's one guy. And on a customer engagement several years back at CounterHack, we were doing an external assessment, and external assessments are super boring. It's when a customer says, we need a compliance check mark that we did a pen test. We want you to look at these IP addresses. No, we don't want you to do phishing. No, we don't want you to do any of the things attackers actually do. We just want you to scan and look at these assessments, but web apps, out of scope. You can't take a look at them. They're boring. We don't like to do them, but for customers, we will, especially when there's other more interesting work to be done as well. We're scanning an organization's network externally. We found Proxybolt Droppy. It's just a file sharing app. It's something you would direct people to say, I need you to send me this big file. Go to droppy.whatever your domain is and upload the file to me. Okay? At the time, we couldn't look at that. CounterHack did an engagement. We found the server. We knew what it was, but we couldn't assess the server because it was out of scope for the engagement. So shruggy, we noted it in a report and we moved on. But for me, it always bothered me. Like, I remember that and thinking, man, if this scope wasn't so narrowly focused, I bet there's vulns here. I bet this is a target that we could really dig into and find some vulnerabilities. It just felt ick. You know what I mean? You know when an app gives you the ick, right? You know when you create an account and you enter a password and you're like, your password is too long. I get the ick, okay? And I'm like, wait a minute, my password is too long, right? And you choose a password and you put like an asterisk in there and you're like, oh no, your password can only have letters, numbers, and underscores and nothing else. Ick. Like, that's like, I know there's problems there. And the same thing here, right? This application really gave me the ick, but we couldn't look at it, okay? But recently, I remembered that and I thought, let's have some fun. Let's just have some fun. Nobody's paying me to do this assessment. I just want to see if it's going to be interesting, and let's use AI to try to help us find vulnerabilities. Now, Proxybolt is an application sold through the Envato Code Canyon App Store. It's an ecosystem of crappy PHP code. Okay? That's what it is, right? So you go to this place, you search, and you're looking for a certain application, and somebody has inevitably written it. It's filled with WordPress plugins that you know are going to get you owned. So, I'm not recommending that, okay? So it's filled with all this kind of stuff. And this application is really meant just for sharing files. But it's got some features, email links, administrative access, creating accounts, drag and drop files, S3 storage, that's an add-on. FTP or SFTP, that's an add-on as well. Add-on, Active Direct add-on, okay? So did I mention that it is $35? Okay, so this is not what you would say enterprise grade software, but sometimes this stuff makes it into the hand of different deployments and different customer engagements. The interesting thing about Code Canyon is that this is all commercial open source software, not free open source software. You pay for it, but you get the source code to run in your own infrastructure. But it really is up to the author to decide how they're going to give you that code, and that's important to us, as we'll see in a couple of minutes here. Now, I read the reviews, and Proxybolt has over 2,000 customers for Droppy, which I think is nice, okay? And there's even some feedback. The code quality of Droppy and its plugins is of the highest superb product. Keep it up, okay? And that comment is from guess what? To which I say, that seems sus. I don't know, okay? So this seems like it's kind of sketchy. Like I feel like, yeah, maybe my spidey sense about this was right here, okay? So what I did was I replicated the environment. I ran this software under the brand Falsimentis. Now, if you've taken 504, you know Falsimentis. It's a little riff on Harry Potter, like Falsimentis, okay? I don't know if I've ever told anybody that before, but this is just a brand name that we use in the class to be able to model out what our target network might be, okay? So I put this up and running. It's at droppy.falsimentis.com, and this is what we're going to attack. Here's the system running right here, okay? And here's where users would upload to the application. But if you go to /admin, if I were actually running the application, this is always. So a friend of mine once said, I don't know why it shut down. Okay. A friend of mine once said, Josh, whenever you're doing a demo, say nothing about what you want the demo to be, and then whatever happens is what you definitely wanted to have happen in the demo, okay? So this is just the Droppy admin console here, but we can't log into this yet. We don't know the password, okay? So what we're going to do is we're going to try to find vulnerabilities in this application by using AI to do a source code vulnerability assessment. Let's go through that 5-step process that we looked at earlier. The first step when we do source code vulnerability assessment is after obtaining the source code, like I paid the $35 for this application from Code Canyon, is to perform some basic analysis. How is it written? What does the framework look like? How many lines of source code are we looking at here? And there's several tools that we can use to be able to evaluate this. So for example here, here's the Droppy application that I've unzipped onto my target system, and I've made a couple of changes here. I've actually already done the vulnerability assessment, so you'll see a couple of extra files here. But we'll do an ls, and one thing we want to do before we use any AI tools is run ls-a. ls-a will show us, of course, hidden files. We're looking for things like .codex, .claude, .gemini, things like that, because those are configuration files that will tell the AI model to do something. And that something might be run malicious code on your system. So before we actually do any kind of assessment with any third-party application, we want to just check it out, make sure there's no hidden files or anything here that could provide some direction that could actually compromise the system that we're doing the assessment from. Okay? There is a claude.md file here, but that's actually my file. So a couple of things that I would typically do here is run CLOC. CLOC is count lines of code. Right? And we can run CLOC dot to be able to count the code to see what's going on, just to get an assessment of what's going on here. So looking at this here, I see there's a lot of PHP files, some JavaScript and some CSS files, and a lot of the other stuff I don't really care too much about. Bourne shell, maybe I might look at that as well. But we're seeing a bunch of files here, and how much is actually blank, how much is actually code, how much is comments, to give me an assessment of kind of what does the source code look like here and what's going on. So this is giving me some insight here. I might run ls again, and I'm seeing there's a directory called files, and I'm guessing the source code is in here. And I see that there's some different application files, and I'm starting getting a sense of what does this application actually do. I'm running it in my own test environment. I'm building my insight. Maybe I'm taking notes about what the application is doing and how it could be attacked. And ultimately, I'm going to share that information with the AI model so that my human insight, where I think the most desirable areas are for vulnerability discovery, can be interpreted and leveraged by the AI model. Okay. Now, one of the problems we have with any AI system is this threat of hallucinations. Hallucinations are a problem because the AI model is generating content that is not true, but the model believes it's true with confidence. That's the big problem of a hallucination. Not that it can be wrong. We can all be wrong, but an AI model is wrong and it believes it's right. Now, in order to use source code vulnerability assessment with an AI model, we need to be prepared to respond to hallucinations. And we need to manage this problem here. Saying, do not hallucinate in your prompt does not work, but it's very entertaining to see, okay? So if you go on GitHub and you look for agents.md, it's amazing to me how many developers are telling their AI models, do not hallucinate, okay? That does not work, okay? That's not a thing, okay? You can't stop the model from doing that, okay? What we do need is a way to verify our findings. When we're using an AI model to find vulnerabilities, we need to be able to validate that those are real vulnerabilities that the model has found. We need a way to be able to automate that validation process. We can do our own automation, manually testing those vulnerabilities, and that'll be some of it. But before we do the manual validation, we want to let the model do that validation for us as well to rule out any possible hallucinations. And one thing that you want to do anytime you're doing this kind of vulnerability assessment is to have a staging asset, an asset that you can direct the model at and allow the model to control to test and find vulnerabilities. Docker is a great way to do this. Docker is an opportunity for us to take an application like Droppy and to run it in a container. You can think of a container as a really lightweight virtual machine. It's not technically accurate, but it's pretty close. And the nice thing about a container is that you can start and stop and restart it as many times as you want, destructively or non-destructively. By using the model to be able to create a Docker configuration before you start your assessment, you're creating an opportunity to validate the findings. By having an opportunity to validate the findings, you are ruling out a lot of potential false positives and potential hallucinations from the system as well. So for Droppy here, I did use the model to help me create a Docker configuration. Here's my Docker file here. And inside of this Docker file, it's just a bunch of statements to build and set up the system. I'm starting from a server that has an Apache web server in PHP installed. I'm using Debian-like apt-get install commands, doing some configuration. I did a little bit of it. I let the model do most of it, and then I tested it to make sure we could start and stop that mechanism. Also, another thing I would recommend when you're setting up these elements is to have a shell script. Here I've got a little shell script that I call Go Droppy, and all it does is start and stop that container, and I tell the model, use this script to restart and stop the container. If you've broken something in your testing, don't ask me to fix it, you fix it, and then continue your testing along the way. The more we can use instrumentation tools to give the model the ability to validate, the better our findings are going to be. Now, another constraint we need to talk about is the context window. Any AI model that you use has a limitation of how much it can treat in memory at a given time, how much it can think about in memory. The context window is measured in tokens, and some of the frontier models that we're working with right now, like Opus 4.8 and Sonnet or GPT Sol and things like that, they have million token context windows. And a million tokens sounds like a lot, but one token is approximately 1.5 English words, okay? So a little word like the would be one token, but onomatopoeia is probably 4 tokens. And so it averages out to about 1.5 tokens per English word. A million tokens still sounds like a lot, but when we're dealing with lots of source code, it can easily overwhelm the model. The model is going to read the source code into memory and not just have the source code in the context window memory, but also tool output, analysis results, working theories that it's working on as well. Some common open source projects like Firefox, written in C++, is about 20 million tokens. WordPress is 10 million tokens, OpenSSL 8.4. These different software tools require a lot of context just for the source code. So if we let the context window fill up, what happens is we get a lot more hallucinations. The more we fill up the context window, even before the context window is full up, there's no real hard numbers here, but empirically, we believe that when the context window gets to about 30 to 50% full, we get more and more likeliness of hallucinations. We're trying to fight hallucinations, but every time the model hallucinates and generates false leads, that's more work that we have to do for analysis. So what we need to do when we're using source code in AI for vulnerability discovery is to manage the context window. There's four primary strategies that we could use for managing the context window. One's called scoping and scaffolding. Front load the project, saying, here's what I want you to do, here's your goals, here's what I want you to look at. It doesn't reduce the source code that has to go into memory, but we can try to limit what's going into the model by excluding certain content. Like, for example, I don't want you to look at SVG. SVG files are XML files. A model might say, well, this is source code, but we can eliminate that, and that helps manage how much context window you're using. We can also apply a strategy called compact and continue. Compact and continue refers to the /compact command. When you're using an AI model, you can say /compact, and the model will look at the context window and try to pick out the important bits to shrink down all that ongoing memory. This requires your interaction and your monitoring. When the context window is getting close to 30%, 40%, 50%, you need to stop the model, compact, and then resume the model again. This can also return less than desirable results because every time you're context, you're losing potential details. We can also use something called hierarchical decomposition, where we use something called an orchestrator. The idea is that we can start with a model, use maybe Claude Opus or Fable or GPT 5.6 Sol, and we can say, I want you to kick off other models. I want you to use what we call sub-agents. And those sub-agents even have their own context window, and they do all their own work independently. So instead of trying to fit everything in one context window, the orchestrator kicks off a bunch of other agents, and they all work on certain pieces and certain slices of functionality. This is useful, and it's a great way to get a lot of work done, but it can get very expensive very fast because you're using up lots of tokens in every sub-agent, and you're losing a lot of control in the process because the orchestration model is the one that's doing all the primary work here. Finally, there's proactive hygiene. You might say, Firefox has 10 million tokens. No way I'm putting all of that into the AI model for analysis. But I can focus on a certain element. You might say, what's the oldest library that Firefox uses? It's a library from the 90s for parsing, I don't know, WOFF files, font files, WOFF files. Maybe that's what I'm going to focus on. This proactive hygiene to say, I'm going to manually slice this up. We need a mechanism to manage the context window. This is your decision-making and your responsibility. Sometimes for smaller projects, it's easy to say compact and continue. For bigger projects, you have to use your insight to say what's the most likely attack surface and choose the appropriate context window management strategy. We also need some kind of a prompt. And I put a QR code here if you want to try to grab this, okay? And I'll give you all the slides and everything at the end of this presentation as well. But I ended up spending a fair amount of time saying, what do I really want the model to do? And I provided it directions. I gave it insight on common vulnerabilities. This is for a web-based vulnerability assessment mechanism. And it came out to about 5,000 tokens. But I have this as my own prompt to be able to tell the model, this is what I want you to do. This is your guidance. I don't have to recreate this every time. I do it once, I tweak it, I use models to critique it, I try to improve it. And then once I have this prompt, I can use it every time I'm starting this kind of vulnerability assessment. One thing that is useful here, though, is not just trying to copy and paste this mechanism, but instead to use it as a skill. When we talk about skills in AI, they're essentially just prompts, but they have a little metadata at the beginning of the prompt. So my prompt here has a little bit of metadata that defines the name of the skill, Pentest Web App, and then a description that summarizes what this is actually doing. The value of the skill is that I can invoke it at any time. I can let the model decide when it should use the skill, or I can tell the model, use the Pentest Web App skill, assess the source code for this application. A skill allows me to take all of that knowledge, all of that understanding that I've built to try to make it something that is reproducible, that I can share with my team, and other people can start to leverage it right away. This is a great way to get started, even if you might not be able to, off the top of your head, differentiate a cross-site scripting attack from a cross-site request forgery attack. The skill can do all of that legwork for you, and it gives the model the insight it needs to find those types of vulnerabilities. So I did do a little pre-recorded demo here, although I don't think we're going to need it, but I did put a little YouTube video where I used Claude for using an assessment on Droppy to find vulnerabilities. But we're going to take a look at what I did last night, and that was using GPT 5.6 Sol. So the new GPT 5.6 models came out recently, and although Mythos has been stealing the headlines, we're so powerful, it's going to ruin the world, pay us and we'll give you access to it. And then, of course, the government said, well, maybe this isn't such a good idea. And then Anthropic backed off and they said, did we say it was going to ruin the world? We didn't actually mean that. It was just hyperbolic. Coincidentally, we're IPOing soon. Not that it has anything to do with that, okay? So there's all this drama going on with Mythos and Fable 5 and all these different things. But to be quite honest, we don't need Mythos. We don't need Fable 5. We don't even need GPT 5.6 Sol, although it does a really good job for us. The models that we have access to are extremely capable. And I think we're going to start seeing a shift in the industry where Anthropic is coming out and saying, Mythos is the best ever. Grok is coming out and saying, we're almost as good as Anthropic's previous generation model, but we're 1/20th of the price. Okay? And so I think we're going to start seeing a lot more competition there, and we'll talk a lot more about orchestration and how that's going to shape the industry as well. So what I did for the assessment here was last night, it took about 40 minutes for this to run, so I'm not going to run it and make you guys watch while it continues here, but I did capture the session, okay? So what I did was I started the Codex utility in YOLO mode, okay? And so when you use an AI tool model, for Codex, it uses a sandbox and it limits what it can do. For Claude Code, it has different classifiers to say, is this dangerous? And it will prompt you to say, are you sure you want this to continue? But that gets kind of annoying after a little while. So what we can also do with these models is use, in Claude Code, it's called TAC dangerously skip permissions, or in Codex, it's just called YOLO mode. So it's called Codex -- YOLO. Okay? And when you're in YOLO mode, what you're basically telling the model is you have free access to do whatever you want on your system. Now, this is generally not a good idea. Okay? Don't go by my example. Okay? Don't do YOLO mode, or if you are doing YOLO mode, do it in a virtual machine or a system that if it gets completely wiped out, you don't care about. There is a big risk of compromise when using these unrestricted, do anything dangerously or YOLO mode here, because the model may decide, I want to install some software, hallucinate a package name, pull down malware, and then without your knowing, you've installed malware through the AI model on your system. I did this last night just for timing because I wanted to try to squeeze this demo in live. It didn't work out, but I did use YOLO mode and just to recognize what that does. Another thing that I do in my Codex interface is that I change my command line or my status line here by running status line /status line is I specify what I want displayed in my status, including the context used here. Okay? By monitoring the context used, I can see where the context is and how much I'm utilizing. This is great in your orchestrator, but we don't have an easy way to model context used when you launch multiple sub-agents. There are some tools that give you like a dashboard to monitor all that stuff's going on. But again, when you're using multiple models, each with their own context window, it becomes difficult to monitor to see where the context windows on all these other sub-agents that are working at the same time. Now, what I did here when I did the assessment, and I'll just switch over to the tab where I did this last night, was I used the skill that I already had configured in my system. So in my home directory in .codex skills, you can see the pentest web app directory. And if I cd to that directory, you can see there's my skill.md file. And this is just the skill file that we linked with the QR code earlier. The model, if I reference the skill by name, or in my prompt, if I say things like, I want a Crystal Box web app assessment, the model knows this is my capability and it will invoke that skill automatically. There's a very similar kind of thing with Claude Code. If you're using that, called a slash command, you just invoke it manually. But either way, it's just a saved prompt with metadata, and you're using it to invoke the model to be able to perform some assessment against the target system. The prompt I actually used was really straightforward. Use the pentest web app skill to review the Droppy application. My current directory is the Droppy application. I've already created that Go Droppy script. It already has the Docker file. The model has everything it needs to perform assessment. Use Go Droppy, the script, to start and stop the target container to validate findings. I'm just reiterating that from the skill that I used earlier, but I'm also explicitly saying use the shell script. And finally, I said use sub-agents to delegate work. So I'm choosing to use orchestration here instead of trying to fit everything in one context window, have the current model, this interface, be the orchestrator and delegate work to multiple other agents. This is going to cost more. I'm going to use a lot more tokens in the process, but I'm going to be able to better manage my context window in the process here. Now, the model starts up here and it identifies that the application is running on this server here. It starts making its own authentication map, doing candidate deduplication, looking at potential exploits. It does reconnaissance. I had to actually stop and start the model again because I realized that I was already using that port number for something else. So I stopped it and then I just said resume here. Okay? But the model then started running GoDroppy. It started using it as a tool. It sees that it's running. And then it just started using different assessment techniques. Okay? It started collecting information. It started using curl with a bunch of commands here to enumerate and interface with the model. And if I keep scrolling down here, the model's keeping working here, looking at different plugins, looking at different commands here, looking at source code. Then it starts using RG. RG is rip grep. It's like grep, but a lot faster. Okay? Rip grep ignores binary files, which normal grep doesn't. And in my skill, I'm telling the model, use rip grep. It's doing a lot of the same techniques that we would do. If I'm manually looking at source code, I'm not starting in source code line 1, document 1, and then just looking. Like nobody's doing that. We're using grep. We're using rip grep to search for potential candidates. What's interesting? What can I find? What does my attack surface do? The model is doing the exact same thing, just much faster with a lot more patience than I have for that kind of assessment. Now, this went on for quite a bit. You can see I'm only at 10%, so this is probably like 4 minutes into the entire assessment. But the model just continued assessing on and on and on. And really, I just kind of watched the context window grow and grow and grow because I did the upfront work. I did the work to say, here's the target that I want you to run. Here's how you can instrument and validate your findings. Here's the skill that I've learned as a pen tester that I want you to apply to do all of this assessment work as well. And I just let it run. And every now and then I'd glanced over, what's the context window look like? Okay, we're at 40%, we're at 50%. It did get kind of high at the end there. I think it ended at like 80% of the 1 million token context window, but I knew that it was also doing orchestration. So there were many other sub-agents doing work and I couldn't easily tell what their context window utilization was. This continued for, like I say, 40 minutes here until, or 30 minutes, exactly 30 minutes, 28 seconds here. And it presented a bunch of findings to me. And now I'm just at the bottom. A lot of the assessment was just in the reporting phase, okay? The vulnerability discovery phase probably only lasted 10, 12 minutes or so. The remainder of the assessment was really writing the reports to be able to meet my own expectations for documentation, for validation, for deduplication of findings. At the end of it, because of the prompt that I've generated, it wrote all of the findings into a directory called report. Inside of the report directory here, it wrote all of my findings that it discovered as markdown files, but it also created shell scripts. Part of validation is me saying, you need to make a script that allows me to validate that that finding is real. Okay? This is a validation script, but because it's identifying a vulnerability, what would be another word for one of these validation scripts? They're exploits, okay? I'm not calling it an exploit, right? We don't want to trigger guardrails on the model, but it is an exploit nevertheless. And I even provided a little context where I could say, allow me to easily replace localhost colon 8888, the local drop E instance, with the target of my choosing. And the model happily complied with all of those findings. By generating that output in Markdown, it makes it really easy for me to review and process that information. And at the end of it, because of the prompt that I generated, it generated a table of all the findings. Now, looking at this application, there are 5 critical vulnerabilities here. There's an auth bypass, an insecure direct object reference attack, stored cross-site scripting, an unrestricted upload/remote code execution, and a supply chain threat as well, okay? Now, you tell me, is that the criticality you would assign to those different vulnerabilities? Would you make an unrestricted upload/remote code execution the 4th highest vulnerability in the finding here, okay? The models don't always do a great job understanding context and why we might treat some of these as higher criticality. So although it is saying these are all critical vulnerabilities, and this is the order from most critical to least critical here, it is not always going to be right. This is our insight that we need to share to provide information about what's going on with these models. But the top vulnerability here I found really interesting. It found a critical unauthenticated admin account creation vulnerability. And if we click in here, it opens up the actual report finding where, because of the template that I specified, it gives me a severity, it references common weaknesses in enumeration, it tells me where that vulnerability is, here's the description, and it gives me some code here. Now, what's interesting is that this vulnerability is in the function install step 4. Remember that, it's going to become important in a second. And this is decoded. This is the comment from the model. And I thought, decoded? I have the source code. What is this actually looking like? What's actually going on here? Let me show you what that function actually looks like. This is the step 4 function here. Does that look like normal PHP? No, it's clearly obfuscated. And if I were manually reading that source code, it would be really annoying to try to decode that. In this application, what the author has embedded is a callback mechanism. So when you buy this application from Code Canyon and you deploy it, it is a callback mechanism to make sure that you're not infringing on the copyright of the software. By checking your license key, it is using a mechanism to make sure you pay the author for the software. And this is actually where one of the top vulnerabilities are in the software. As part of the setup process, when the system is set up, it goes through this validation mechanism to make sure you bought the software, but it's missing an exit statement. When the software is appropriately set up, like you've deployed it in production, it's supposed to check you have a license key and then exit, but it doesn't. It doesn't exit, and it goes right to the default, hey, let's get started with a new admin account. But you have to be able to call that in just the right way to be able to add a new admin account. Fortunately, Codex did that for me. It made a shell script for me here where I can specify a target system, and I can specify a suffix and a default username and a default password against that target system. So here, if I want to attack the system, what I can do is redefine the base parameter. And I can run the O1 critical unauthenticated admin account creation validation script, not an exploit, but it really is an exploit, okay? And I don't know why this other server instance keeps exiting here, but let's start that one more time here. Okay, this time I have the server up and running. It sent the unauthenticated post mechanism to create a new administrator account with my username and password 1. So now what I'm going to do is I'm going to go back to my browser. I'm going to go back to the Falsimentis login page here. Login is jwright@hasborg.com. Enter the password, password1. And now I'm signed into the application, where I was not able to do that before because I didn't know about that vulnerability. Okay? This is not the only vulnerability that we found in Droppy. When I found these vulnerabilities, I did report them to the Droppy author, the guy that made the software, and he said, thanks, I fixed the most critical of them. And I was like, well, I think that gives me free reign to do whatever I want now, okay? Like I reported it, okay? But like, you know, the thing that's interesting is that if you, like if we go to this page here, and one thing I would do is look at the source code, kind of see like, you know, okay, so the title is always Droppy online file sharing. And then if you go to Google and you say in title, and then you paste that string, like you'll find all these other public instances of the software running that's just being used on the internet. And I'm fairly certain none of these are patched because this is, I'm guessing, not the kind of thing that people are really looking at and trying to monitor the security of these different target systems here. I'm not trying to drop O-Day on everybody here. Like that's not my goal in this presentation, although I kind of just did, okay? But I think the important point here, okay, forget about that. I didn't say that. The important point here is that you don't need to be an expert pen tester to find vulnerabilities in software today. An AI model can help you with a lot of that legwork. And I think this is a really important kind of pivot point for our industry. The number of people that could sit through, read software, and find vulnerability was very small. Now it's very, very large because of what AI models provide us the ability to do. And the thing that I think is so interesting about that is that it's great and it's terrible at the same time. We can feel both emotions. That's okay. It's great because we have a tool that will help us dramatically, vastly improve the security of software. How long is that going to take? That's the big question. The problem is what we do in the meantime. If it's so easy to find vulnerabilities like this using canned skills, AI models, we have to have some understanding. It's going to be a rough patch until we've dramatically fixed all these vulnerabilities. I love seeing articles like this where the AI vendors are saying, we're investing $12.5 million in the Linux Foundation to improve the security of software. That's amazing. Okay, I love seeing that. I think these vendors that make AI technology should be doing that. But think about the very long tail of software packages. Okay? On the x-axis, we have popularity. On the y-axis, we've got the number of software packages here, right? So popularity, Linux, Firefox, VLC, tools that you hear about all the time. Like those are really, really popular software packages. And then you've got stuff like libraries that you've never heard of, libLZMA that everybody uses, but we don't really think about a lot, okay? And then you've got things like 7-zip, and we're getting further and further down the elevator here. But what's all the way at the right? Droppy, and millions of other crappy software packages out there, okay? Here's the thing that bothers me the most. Investing $12.5 million is going to move the needle a little bit up here. Who's investing here? Nobody's investing in this, okay? A little bit. I'm investing a little bit of it. Yeah, a little bit, okay? Attackers are investing in that as well. And I think this is going to be the new normal. Find the weirdest thing you've got in your organization, get the source code, and develop a 0-day. Okay? And that's going to be a trend that we're going to see a lot more of. And this is where you come in. Okay? Think about orchestration here for a second. Okay? Now, in my mind, I think, oh, it's kind of like an orchestra, which maybe seemed like, I'm a little basic, but like, think about like an orchestra, right? And instead of the conductor, we have our orchestration agents like Claude Code. This is the orchestration model where instead of having one agent do the work for you, you tell the one agent, You're in charge of launching all these other sub-agents, and they're all going to do this work for us. Okay? And you can dramatically, vastly improve the amount of work that you can get done at cost. This is where models start becoming expensive. But I think we're seeing a shift in the industry. And I think if instead of saying, I'm all in on Anthropic, you might say, you know what? Anthropic's good for some things, but not other things. So maybe I might use Anthropic for some things and as my orchestrator, but I'm going to use ChatGPT for the things that ChatGPT is better at. Or I might throw some Gemini in there for the things that Gemini is really good at. Or I might throw in some Grok in there for things that, it's cheap. Grok isn't the best, but it's super cheap. It can do a lot of good things for me over here. Or even open weight models like GLM, okay? Or Qwen or DeepSeek, or these models that we can run even on commodity hardware. For a lot of tasks, those models are sufficient. In fact, we don't even need Claude to be the orchestrator. What I think we're going to see in the industry is the introduction of AI routers. An AI router where now we're integrating, we're bringing our own expertise, our own value to the proposition here, and we're letting an AI router figure out what's going to be the best analysis, what's going to be the least cost, and how we can distribute this task across multiple AI agents. We're not quite there yet, but I think in the next 6, 9, maybe 12 months, we're going to see a big shift in our industry, people recognizing how much these AI models actually cost us and distributing that workload across multiple vendors instead of saying I'm all in on GPT-5 Soul or any single AI vendor. Here's the big takeaway I want you to leave from this presentation. AI is faster, it doesn't tire, it doesn't get bored, but it's not useful without you. And I think this is something that a lot of people are starting to realize that we probably could have wisened people up to a year or two ago, but people need to make their mistakes, so we let them make their mistakes. Who are we talking about? Ford Motor Company, okay? Ford Motor Company decided we're going to go all in on automation, and we're going to lay off all of our different employees here. And then, lo and behold, they realize, wait a minute, that didn't work for us. Now what are they doing? They're rehiring those people. It's the most Elon Musk thing I've ever heard, right? Like, so Elon Musk, right? He goes into a company, he's like, we don't need you or you or you. You're all fired. You're all out of here. And then when things start breaking and they realize they really needed those people, they go, Mr. Musk would like you to come back working for the organization again, right? Meta, same situation. Meta said, we're investing in AI, and they laid off 10% of their workforce. Part of that was telling the bottom 90% that you need to pick up your game, otherwise you're going to be in the next round of layoffs. And then what happened? Morale went down the tubes. Nobody at Meta is happy with their work anymore. So Meta said, we realized this was a big catastrophe, so we're going to make it better. We're going to bring back snacks in the break rooms. Okay? Thanks, Meta. That's fantastic. Okay? Yay. Okay? This is amazing. Okay? Here's the thing that I think is so important. You are much better than an AI model. There are certainly things that AI models can do faster, better than us. That's great. But it doesn't work without you being involved in that equation. None of this vulnerability discovery stuff happens without you. A model can say, here's my list of findings, but what does that mean for your organization? You provide the expertise. Our job is to figure out how do we leverage AI where we're still in charge and our names are still on that final product to deliver more results, better engagement, to relieve us of the doldrums of that rudimentary work that we probably didn't want to do anyway, but still provide our expert level expertise to make sure that the product that we're delivering is going to be the quality that we need it to be. So, in summary, your investment in decomposing tasks and orchestrating AI is what makes it valuable. You can't just say an AI model, hey, find vulns. It might find vulns, that's great, but it's not going to be the quality assessment that we would like it to be. In order to get those quality results, you have to put the legwork in. You have to look at the source code, figure out what's going on. You don't have to be able to read PHP, but you have to understand what the attack surface looks like. what to focus on. You have to understand the constraints that we're working with, how hallucinations are real and how we mitigate those. We need to understand the management of the context window and the different strategies for doing that. Your investment in assessing risk and understanding the threat is what makes it valuable. Not the markdown report that the AI model generates, but your interpretation of that, your understanding, your placing it in the context of the organization. That's what makes it really valuable. There are a lot of opportunities out there. And I hope today people look at that, what I did with Droppy, and say, that looks like fun. I want to do that. You don't even need to pay for an AI model. Use free tier in Claude Code or Codex or Gemini or Grok to be able to do some experimentation. Start with something small and then get bigger and bigger. It's fun. I just scrolled on Reddit for half an hour while I let the AI model do its thing. And then I was dumber at the end of that. But like, you know, I had a good time doing it, okay? These are the things that we can do to try to find vulnerabilities and to dramatically improve software security. I'm the author of SANS Security 504, sans.org/504. I also contributed with the team at CounterHack for Sec 543, which is AI-assisted source code analysis and exploitation for pen testers. It's a new 2-day class. I think it's awesome. It goes into a lot more depth and a lot more context than we have time here for today. So if you're interested in those things, that's fantastic. But if not, my encouragement to you is to get out and try it. Now is the time to make mistakes. Now is the time to learn. Now is the time to think, I need to read up on a lot of these AI things. How do I use these things? And it's really just putting yourself out there, trying, failing, picking yourself back up, saying, you know, sometimes, hey, you know, maybe I should become a sales engineer. I hear they make good money. And then saying, no, I'm going to double down on this and to make the world a safer, more secure place. Thank you. We have a couple of minutes if anybody wants to ask questions. I'm happy to do that, and I'll repeat the questions for anybody. I can't really see you all very well, but does anybody have any questions that they'd like to ask? Are there any SANS college students here? Okay. In addition to be the faculty fellow as an instructor, I'm also the dean of students for the SANS College, which is a job that I love because I get to spend so much time with brilliant people that are just investing so much of themselves to really do really great work. If you haven't checked out the SANS College, sans.edu, and you can earn an undergraduate or a graduate degree or certificates in a whole program of study. It's a fantastic program, and you end up saving quite a lot of money if you go through the program as well. So there's a lot of great things going on there too. So definitely check that out. And anybody, college students, if you haven't met me yet, I'd love to be able to speak with you. What questions, sir? Yeah.
Okay. First, I know we have like I'm still I think
Wonderful question. Yeah. So the question is, when we're developing code using AI systems today, can we still use these techniques? Is this going to help us as well? Right now, yes, dramatically. Because when we're seeing people vibe coding things that are not professional programmers, they don't know the things that they don't know. So we're still seeing a lot of vulnerabilities in that kind of vibe coded world. Eventually, I hope the models get a lot better and we see vulnerabilities dry up a lot. That will mean less work for me as a pen tester, but I think that would be a much safer world, and I look forward to that. We have a long, long way to go. Remember that long tail that we were talking about, right? That long tail, here's like Linux, here's like 7-zip, and out the door is all the other source code that's being developed right now. Like we have so long to go before we catch all those things. I'm hoping the AI models will generate more secure code. And I think it's a great time too, because honestly, if you're using an AI model to generate C code, why? We should be doing memory safe code now, which was not an opportunity that we really had 20 years ago. The market's changed, the tools have changed, the programming languages have changed. I think it's an opportunity to do much better. I think that we're still going to see a lot of crappy code, but eventually I hope the models stop producing that, and then we won't see software vulnerabilities anymore. Maybe that's a pipe dream, maybe I'm an idealist, but that's my hope for the future. Thank you. Okay, all right. Thank you, everybody, for coming. This is a huge sacrifice. I know that you give up on other things that you want to do to be here to listen to me. There's never enough time for all the things that we want to do in this world, and I thank you for all your time here as well. I'd love to be able to meet you and talk to you if you want to hang out for a little bit. Otherwise, have a good night. Take care of each other. I'll see you all next time. Thank you.